Good morning, everyone. My name is Andre, and today we will be talking about the new version of our software, PoligonSoft, the free version of the program. The free version is a program dedicated to solidification simulation, meaning it allows us to predict at the project stage the possible shrinkage defects the part will have. It allows us to predict porosities, shrinkage cavities, microporosities, and much more. During these classes, we will be seeing how to achieve the highest possible quality in simulations, how to create meshes, and how to analyze the results. Today we will be talking about a very important aspect of the work. We will be talking about the correct way to work with meshes. Why is this very important? Because the free version has a limitation of 500,000 polygons for each simulation, and if we exceed that amount, the calculation cannot be executed. So it is very important to know several things that will allow us to create meshes with that number of polygons for real projects. We will be working with two examples. The first example is a fairly simple part, a permanent mold simulation containing two pieces, its two-half mold, and we will be working with a larger part, which is this sand casting simulation. Here, as we can see, the part does not have the mold drawn. The PoligonSoft free program allows working with a process called virtual mold, which allows us not to calculate the mold, but to simulate only the part. This is a way to reduce the required number of polygons, although it causes a loss in simulation quality. The simulation becomes a bit less precise, but it still gives us a general picture of how solidification will occur, and is very useful if you need to use the free version for large projects. Let's begin. First, I would like to talk about the necessary requirements that we still need to address in our CAD system before starting the work. The first thing we have to do to reduce the number of polygons when creating our mesh is to unite all our parts of the piece, the feeding system, into a single solid. Actually, the mesh can be created in parts, but that will generate many more polygons than we need for our work. That's why it's much better to unite them into one. Besides, this simplifies the work of the mesh calculation algorithm itself. We do the same with the mold. We unite the two parts of our mold into a single piece. The second thing I want to talk about is the subtraction of the part from the mold. If I turn off the layer with my part here, I can see that our mold is simply a rectangle or something that has its own shape. It doesn't have to be exactly a rectangle. The important thing here is that the part is not subtracted from the mold. The mold is solid, and the subtraction work will be done in the mesh creation process. You cannot subtract it in the CAD system because it simply won't work. In case we are working with the virtual mold, simply we do nothing, unite the part into a single solid and export it. To work in the mesh creation module, we need to export to the step format. We already have our format ready. We can begin creating our mesh. The first thing, obviously, we need to do is download the program. The program is available on our website, PoligonSoft.com. Here we go to the user page. If you are not registered, register and download the installer. The program does not require any serial number for installation. It does not require any internet activation. You can use the program if you wish, on a local machine without an internet connection. This guarantees you that there will be no data theft, that there will be no loss of confidential information. We did this on purpose, so there would be no doubts about the security of your data. Once the file is downloaded, we install it like any program by clicking Next, 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 Next. And after installing it, it will appear. Let me close all this. An icon will appear here that says PoligonSoft 2024.1. And if we run it, we can see this window here. Here we have 4 available modules. The first module, the mesh module, is exactly the one we are going to work with today. It is a module dedicated to mesh creation. As its name says, we will see the master module in the next class. It is a module dedicated to working to setting up the simulation of our process as such, and it is where the calculation is performed. Although there will be a class dedicated to the master module in the free version, while the class has not been released, you can easily use the class from the paid version, which is already available on our page. And the Mirage module is the module dedicated to data analysis. It is where you can see the results of our simulation. There will also be a class dedicated to how to work correctly in it. Today we are working with the mesh module, so let's run it. They're done. The first thing we need to do here is switch in this top tab to the working mode with geometries. The parameters open up. We don't have any geometry loaded yet. Let's do it. Click File, Import, and select the step format. Here I will go to the folder where I have my files saved. Let's start with example number 1. When we select the file, the first thing we see is a question about what we want to do with the units of our model. Here I always recommend clicking No and leaving the original units in the CAD system, whether they are millimeters or inches. You don't have to do any type of conversion here. Click No. The second question the program asks us is about partitioning. Partitioning is exactly the process of separating our project into logical parts. That is, initially we had the whole mold, and the mold was simply a cube, and we had a part located inside but not interacting in any way with the mold. When we clicked Yes here, the program analyzes our model and creates logical parts. Here, if we can see, a new line called partition appeared. And if I turn off, for example, solid 1, which in our case is our part, I will change its name to Know It. This will be our mold. Here I can already see that the program subtracted the part from our mold and made a separation. We are done here. Let's start creating our mesh. To do that, we switch to the mesh module inside here. We don't have any mesh created yet. Let's create it. Let's start by setting the parameters for our mesh in general. First, we will make a mesh of the entire complete part, and then we will make a submesh of the inner part of our casting as such, to increase the mesh precision, but only in the inner part. First, we select our partition, all of this, period, and click the button up here called Create Mesh. A tab appears with the parameters we need to assign. I recommend before creating a 3-dimensional mesh, which is what we will need. I always recommend making an intermediate 2D mesh so we can roughly see how our mesh is looking, because the 3D calculation process takes quite a while, and to adjust the parameters, it's always better to create a 2D mesh first. Let's go here. Here we select the NetGen 1D 2D module. It's an algorithm that allows creating meshes with very few polygons, but the problem with it is that it doesn't always work. Now we will try to do it, otherwise we will switch to another algorithm later. We select NetGen 1D 2D, and in the hypothesis we have to set the calculation parameters. We click this here, select parameters, and here we have to put the dimensions of our mesh. Since we don't know the measurements roughly yet, I always put 10 and 1. In case the mesh up too large or too small, it can always be changed. And the precision for simulation purposes, since we have a limited number of polygons, we always select coarse here. If we set more precise meshes, many polygons will be created, and it won't fit within the established polygon limits. It won't fit within the 500,000. Click OK, apply, and close. As we see here, a mesh appeared with a sign indicating it hasn't been created yet. We won't calculate it yet because we still need to set the parameters for our inner mesh, for the mesh of our casting. I right-click with the mouse, and here I select Create Submesh. We're going to create a submesh. This submesh will be inside the Mesh 1 mesh, which is the mesh we made, and it will work only with our part, only with our casting. We select Casting here, as we see the geometry used will be the casting. Likewise, we switch to 2D, 3D mode, select NetGen, Parameters, and here we put in the general mesh. We had put 10, let's say, I don't know, let's put 3. And the minimum size we put 1. This minimum size is not very important, simply because if the size doesn't fit to obtain a triangle in the geometry we are calculating, the program will reduce it and the triangles will become smaller. Here, the one that influences the most is the maximum size. Likewise, we select Coarse, OK, and we apply. Now we can start calculating our mesh. Let's see the submesh first. Click Compute Submesh, or we can also select this button here, which is the same. The program made a mesh for us, but as we can see, there are 2 parts here giving us an error that the algorithm couldn't handle. We can see them. This here, for some reason, the algorithm couldn't make that mesh, and it's here. In case things like this happen, we can use the other mesh creation method available in the program. Now let's see how we do it. We simply delete these meshes. Again, we select our general mesh, again create submesh, we go back to 2D, and here we select the Gmesh 2D method. Let's go to its parameters. Here the parameters window will be different, and here we have to select, just like the previous time, the minimum size, which is a relative number that anyway won't be respected if it's not possible, and the maximum size of our triangles. It's ready. Apply and close. Ah, I forgot to select the geometry. The geometry here was for the casting. Done. Let's calculate our submesh. They're done. We can see how it turned out. The mesh has a quite acceptable size. Everything is perfect. It's very, very good. Close. And now let's do the calculation for the mesh in general. We simply switch to the Mesh 1 row and click Calculate again. Now we have 2 meshes, a general mesh for our entire mold and an internal mesh, which is our part. I can, if I want, turn off the visibility of one, the visibility of the other. Everything can be checked here. What do we have to do now? To be able to create a mesh with the necessary characteristics, I always recommend executing this command here. What does the command do? The command checks our mesh, and in case there are triangles with parameters outside the established limits. Here we check the minimum angle of the triangles, the aspect ratio, and the size of the edges. This is completely automatic, or if you want, you can do it. Simply click Correct and wait for the program to finish its execution. It's important to mention that it's not necessary to correct all the errors in the mesh. If the mesh is valid, meaning there are no problems here with loose faces, we can leave several errors. As we can see, the geometry problems were almost all resolved. One triangle remained with ratio problems. And 16 triangles whose only problem is that they are very small. But this does not cause any problems in the calculation. We can leave it like this. Now we close this window and our mesh is ready. The only thing left is to calculate the 3D mesh. We were working with two-dimensional meshes. To calculate the 3D mesh, simply without making any adjustments, we execute this command here, compute 3D mesh. The program starts working. This process will take a little while, so I might speed up the video a bit. I'll be back when it finishes. Okay, we're back. As we can see, our mesh has been created. Actually, we could have set more precise parameters. The number of volumes is 361,000 polygons, meaning this model can be processed in the free program without any problem. Now we close this window. All that remains is to save our mesh to be able to work with it in the master module. We select the mesh, right mouse button, export, and here we export our mesh in MED format, the first option. I had it saved and well, I'll give it some name. Done. To be able to check that everything went well, I'm going to run the master module. We will talk about this in the next class. Now, the only thing I'm doing is simply checking that the model can be opened in our program. They're done. As we can see, everything opened, everything is perfect, everything works. Now let's work with our second example. I'm going to close this. We run the mesh module again to work with the second mesh, and we are going to repeat the steps we did last time. We open the geometry module. We go to File Import and open the step file we have. In this case, it will be example number 2. Again, we click Not to change the units. And as we see this time, it opens without asking anything about partitions, for the simple reason that there's only one part here. There's nothing to partition. It's ready. We return to the mesh creation part, to the mesh module, select our part, and let's start with the necessary parameters. Again, we go to the 2D tab, select NetGen 1D 2D here. Let's start with the default parameters, 1, 10, and we'll see what mesh quality we get. Course. Okay. Apply and close. Since we only have one mesh here, we can calculate it directly without any additional steps. Let's see what happens. As we can see, this time we again have several errors. The NetGen algorithm is not working for us. There is some problem here. There must be another one somewhere else. Yes, everything with this broken mesh we have here, there's something NetGen doesn't like. Just like last time, I can simply delete this mesh. We set new parameters, switch to the GMSH 1D 2D algorithm, and put the dimensions of our mesh here. 1, 10. Okay. Apply and close. I forgot again. To set it, sorry, I'll repeat it. The geometry is this one. (2D) 110 are already set. Here likewise, to be able to control the quality of our mesh more precisely, we can select this calculation algorithm here. Frontal Delaunay, I don't know how to pronounce it correctly. It sometimes works better than the automatic one, but really you can use whichever you like best. It's all more or less the same. This time I will select it so you can see the difference. Okay, apply and close, and we execute our calculation. As we can see, our mesh was created. It has 121,000 parameters in its two-dimensional mesh. I get the impression that, with these measurements, it won't fit within the necessary 500,000. Anyway, I'm going to do the 3D mesh calculation and see what happens. I click Compute, calculate the 3D mesh, and let's wait again until the calculation finishes. Could not create the 3D mesh. We are getting some error in our 2D mesh that prevents us from creating a 3D mesh. What to do in these cases? We will have to return to the geometry module. We delete the mesh we have already made and return to geometry mode to be able to check our model and see what is happening. We select the part we're going to work with, exactly this parametric body here, and we go to the automatic model repair module. Here we select shape processing, and this tab will open. It's a tab that has several automatic model checking modes. We leave everything that is selected, but I recommend also adding all these methods, meaning that these three are the only ones we will not use. Click Apply. I haven't selected the part, and as we see, the automatic model correction program detected 25 errors to correct. Click OK. Apply. And as we can see, a new model has appeared here that is already corrected. I can turn this off so it doesn't bother. And now we're going to work with this new one. We return to the mesh module. We select the line that has our fixed model and repeat all the steps again. First, I'm going to try with NetGen. One course, everything is correct here. Okay. Let's see if our mesh calculates. Done. The mesh has 94,000 faces. It seems to me that it still won't fit within the 500,000. Let's calculate it to see what happens. But first I'm going to do the node repair. As we can see, we have around 100 incorrect triangles. Let's correct them. All right, as we can see, 18 triangles remained that are smaller than the established norm, but we can leave this as is. It doesn't matter. It's simply an informational error that will not influence our calculation in any way. Close, and let's compute the mesh. 3D, we still have the doubt that it possibly won't fit within the established 500,000 limit. Let's see. I'm going to speed up the video a bit since this process will take a while. The calculation has finished. As we can see, it's a shame, but we went over just a little bit. Our mesh contains 500,038 parameters. So we will have to recalculate it again. Close. How to do this process? It's quite simple. We don't have to do anything new. We simply go to the algorithm applied here to this one, which are the parameters applied for the 2D mesh. Click Edit. And here, for example, since we are very close, we are just a little short, let's set the maximum size to 11 instead of 10. Okay. Once it's ready, click Mesh again. And we are going to compute our entire mesh. Okay, we're back. Look at this. I'll have to do the work a third time since with 11 we still exceed by 1,700 polygons. Okay, we close again, go to the parameters here, edit hypothesis and select 12 so it fits. Click OK, and again we go to the calculation. Okay, finally we have obtained the necessary result. As we can see, our mesh has 473,000 polygons and can be easily processed in the free version of the program. Close. All that remains is to select our mesh and export it in MED format. To be able to work in the next class in PoligonSoft, we are going to set up the simulation and do two calculations, one for the permanent mold and this one here, which will be in sand with a virtual mold. Close, and let's go to our PoligonSoft program to see that everything opens. Everything is ready now. As we can see, the part ended up a little tilted. How to solve these types of problems? We will talk about it in the next class. Today, we have learned exactly how to achieve a mesh with the necessary quality and containing fewer than 500,000 polygons. As we can see, it's not just about small parts, about educational things. We can work with real projects, with large parts, staying within the limit of 500,000 polygons. Thank you for your attention. In the next class, we will continue with the parameters that need to be set to perform a simulation. And today we have finished. I hope the information has been useful to you. Goodbye.